All right, the point of this question is to determine when f of x is increasing and decreasing using derivatives and the first derivative test. So first, it's a good idea to figure out where it may be switching from increasing to decreasing, which is going to happen at the critical numbers. And the critical numbers will happen when the numerator equals 0. That doesn't happen on this question. And then also where the denominator equals 0. And x plus 1 squared. We could do the square root of both sides and subtract 1 from both sides. Looks like -1 is our only critical number. So it is not guaranteed to switch directions there, but it is likely to switch from increasing to decreasing or decreasing to increasing. Okay, so to actually figure out what's happening here, I will take a point to the right of this critical number, and I would like to plug that point into the first derivative. And if I rewrite this with the exponent rule, then I can just apply the power rule, bring the power down, lower the power by 1, and consider chain rule, but it's not needed there. And so the derivative at 0 is -2. I don't care so much about the 2, but just that it's negative, because we know if the derivative is negative, the slope of the tangent lines are negative, therefore the graph is decreasing there. Okay, I'm going to try the same thing, but now I'm going to pick a point to the left of that critical number, like -2. And let's say -2 times -2 would be +4, times another -2 would be a -8. Okay, so it looks like the slope of the tangent line when x is -2 is +1/4. Again, I'm not so interested in the 1/4 here, just that it's positive, because if the derivative is positive, the graph is increasing there. So now I can see my increasing intervals all the way to the left up to -1. And I can see my decreasing intervals, starting at -1 forever to infinity.